Hello everyone, welcome to another video. So today we're going to be doing the reality check 3a. This is for the indices chapter 3. Okay, so our first skill is really just simply to write down all the laws of indices. So if you can't even write down the laws, you don't even need to talk about anything else, right? So you need to know the laws to use them. So you can see that in my notes here, I sort of wrote it in it's like my own way of remembering, because there's so many of them, you can't remember everything. So you can see that what I write here is same base, if they times together the power will plus. That's how I remember it. So same base divide the power will minus. So you can see that I wrote an example here, right? So that's the point. Write down an example using each law. So I'm doing this one. So same base, when they times together, the power will plus. You can see that the power is x plus 2. In the same way, if it's exactly the same thing and it's divide, so the power will minus, so it's x minus 2. Okay, so that's the first two laws. And then the other two I do is when the power is the same. You can see that in this example, the power is x, the power is x. So the power is the same. And then I can actually times the base together. So this times together is 20. In the same way, when it's divide, the base will divide. And then it's still power x. Okay, so the next one will be, this is what I call the bracket power. So something, then bracket power again. So you can see that this is 3 to the power 2x, and then I bracket power. So that's why these two will times together. That's why it's 2x plus times 5, 10x. And then for number 6, the one I did was I did the flip one. So when you flip something from either denominator to numerator or the other way around, the power will negative. So you can see that this is 3 to the power minus x over 1. So when I sort of shift it downwards, it becomes 3 to the power x. There's no more negative. Okay, so you do the same thing when you shift up and down. Okay, so next one is anything to the power 0 equal to 1. So it's quite obvious. Anything to the power 0 is 1. And then this is probably the most complicated one. Now you can see that I have x to the power something, then I root 5. So the root 5 will always means 1 over 5. That's why it's 3 over here, and then it's 1 over 5 here. So you've got to remember this one. So these are the basic laws of indices. So this level 1. So when it comes to level 2, we have generally two type of question. One is simplifying, and one is solving. So I'm doing it left and right, so you can see the big difference here. Okay, so let's do all the left side first. And you can see that this is the easy version where we use about 1 to 2 laws. Okay, the harder ones will use many laws. Okay, so let's do the simple one first. So when you see this is two things times together, right? So the number and the number will times the 6. So the 2 and the 3 will times together to get 6. And then you have the base x times together, and based on our law number 1, you see the same base times together, I'm going to add the power. So it's 10 plus 7 equal to 17. So let's do this one. So this one will be a bracket power situation. So I'm using this law, right? The bracket power. So based on that law, where is it now? Here, I'm going to square everything. So you can see that this is 3 square. That's why it's 9. Because 3 times 3 is 9, right? So when it comes to this x to the power 7, based on the law, the power will times together to get 14. Okay, so that's solving. So so let's finish all the solving first. On the next page, there's still solving. So you can see that here is a bit more difficult. I have the x to the power minus 3. I don't like it to be negative, so I'm going to shift it up. And that's why it's on the numerator. And this 2, I'm going to apply the law to get negative 14. And then from here, I'm multiplying this 2, right? So I like to shift this one down to the denominator, and then I sort of cancel it to left 11. Okay, so for the last one, this is just a direct apply of the last law. So that is x to the power 2 over 3. Okay, that's it. So now let's go back and do all the solving. Now the solving is significantly more tricky because you need to figure out a few things. What is the base? So I see 81, I see 27. So actually 81 is just 3 to the power 4 is 81, and then 3 to the power 3 is 27. So you've got to be quite familiar with all these power numbers. Even if you do not know, you can always use the calculator and try, right? So see what I do is something to the power x. So I change this something, which is 81, straight away I change it to 3 to the power 4. That's why you can see that it's 3 to the power 4 to the power x. And then for the 27, I do the same. So I swap it over to base 3. So the point is to get the same base. And then I'm going to use my laws of indices to simplify. So this is the bracket power one, so it becomes 4x. And then here, no change. And at this moment, I've achieved 3 to the power something equal to 3 to the power something. That's why the two powers must be the same for these two numbers to be the same number. So effectively, it is 4x equal to 3. So that's where this one comes from. And then I'm just going to divide the 4 to get the answer. So in this case, I have the same situation, right? But this is the case where the power needs to be the same, so it's a bit more tricky. So in the first step I do is I'm going to divide the 2 over to get 16. Now I have something to the power 4, so I need to make this into something to the power 4. So just by pressing the calculator I realize, okay, it's 2 to the power 4. And then at this moment you can see that the power is the same. So for these two numbers to be the same, x must be equal to 2. And that's why the answer is this. Okay, so for the next one, we have 4 and 64. So again, you need to know that 4 or 64 can be written as 4 to the power 3. Okay, so I'm swapping this 64 to 4 to the power 3, and then I want it to be 4 to the power something equal to 4 to the power something. So this cannot be in the denominator. I'm going to shift it up and make it negative 3 power, right? So it's 3. When I shift it up to the numerator, it becomes negative 3. So at this point, again, it's 4 to the power something, 4 to the power something. That's why the power is equal. So that's why it's this power equal this power here. And then I'm just going to solve my Sec 1 algebra. Okay, so this is the tricky one here. So I have 25 to the power x equal to 1. So 1 is a bit tricky because anything to the power 0 is 1. So I choose to write it as 25 to the power 0. So at this point, I have the base 25. That's why x and the 0 must be equal. So that's all the simple solving. So at this point, I'm going to do something more difficult. This is what they call the level 3. It's still simplify and solve, right? But you can see that this is much harder because you're using like many laws and the numbers are like ridiculous. Okay, so let's just go through this quickly. So if you're interested in this, I'm guessing you're one of the better students. So I'm not going to go through in such fine details, right? So you can see that I have 16x and this y to the power something, everything cube. So the cube needs to go into every term. So 16 cube like that, x cube like that. And then to cube this, I simply times the two things together. So I press calculator, I get this. And then I have the root 4 outside, right? So root 4 is effectively equal to power 1/4. So this is actually this whole thing, power 1/4. And I'm going to apply the power in. So this to the power 1/4, you get this. This one 1/4, you get this. This one 1/4, get this. And then at this moment, I can see that it's negative power. It's always positive index, right? So this one needs to go down to the denominator. That's it. Okay, so for the last simplifying, this is actually a bit easier. So this is these two terms to the power 1/3. So the 1/3 times in, and then same thing, these two terms power 1/4, the 1/4 goes in, and then I'm at this stage. So now I'm going to combine the a. So a times this a, the power will plus. That's why it's plus. And then this b and the b times together, this one and this one will minus. Sorry, it's still times, so it's still plus, sorry. Yeah, so it's 2 plus this one, this way is minus. Okay, and then I'm just going to press calculator and simplify, and that's the answer. Okay, so now let's do the solving, the hard solving. It's actually not much harder, right? So you can see that I see 81, I see 9, I see 3. So clearly I need to change all the base to 3. So again, 81 is 3 to the power 4. The power never change. 9 is just 3 square. The power never change. So the 3 is fine, I leave it there. So now I'm going to use the law of indices. So this is our bracket power, so it's become 4 times this to get this power, and then this is 2 times this to get this. And at this moment I want to divide this 2, so that's why it's 16x minus 4 minus 4x. That's why I'm left with 12x minus 4 and equal to, so I'm at this moment I have the 3 to the power something, so these 2 power must be the same. That's why I reach here, I shift it around, I solve. Okay, so for this one, it's the same trick. I change 25 to 5 square, 125 to 5 cube, and then I apply the law of indices. So this is I do quite fast. So it's x, because of the divide is x minus 4x minus 6. So that's where this thing come from. I sort of simplify it, and then the 2 powers, these 2 powers will be equal. I shift it around, I solve. So this is the end of the first part, skill number 1. Hope you learned something. Thank you and bye-bye.